Hi everyone, hope you're having a good holiday break. This video is going to go over the canMove method from the bug class. I'm sorry I'm all over the place here. Um, while you're watching this video, a couple things to keep an eye out for. Let me know if the volume of my voice is too low or too high. You may have to lower your own volume. I did test it, so I think where I am is okay, but let me know in class when we come back whether or not it's good for you guys. Also, the resolution of the video is fairly high. I'm going for full screen. I have a few options that I can try turning it lower, but that does mean I can't fit as much things on the screen themselves. I'm also trying to talk a little bit slower, so let me know if that also works out, you know, from your end, or if you want me to go faster. I'm shooting for 10 minutes max for this video, so we're only going to talk about just one method from the just one method from the bug class. So we'll see how that goes. So first of all, we are talking about GridWorld. To access the bug class, you do need to get to your GridWorld code folder. As you can see where my mouse is pointing, it says GridWorld code my version. Again, framework folder, info, GridWorld, actor, and then we have our various classes for GridWorld. Here is the bug class. If you double click on it, it'll open it in Notepad or Notepad++ or whatever it is that you use at home. And when you do so, you're taken to the bug class. Let me scroll to the top here. You're taken to the bug class, and the canMove method is all the way at the bottom. I've taken a screenshot and stuck it here in OneNote so that I can draw onto the screen. We'll see how that goes. I may be popping back and forth. I've watched some of the old, this is like the fourth or fifth version of this. I've watched some of the old videos, and whenever I start switching videos start switching screens very quickly, it can be hard to follow. So I'm going to try to do everything a little bit slower. And again, let me know if any improvements I can make for the future. Alright, so what you're looking at is canMove method for the bug class. Let me switch over to the actual file again. And the canMove method is used in the act method here. I've highlighted it blue with my mouse. The act method says if the bug can move, it'll move, else it'll turn. So the method is called here. It is a predicate method, meaning it returns true or false, and what it looks for is whether or not a bug can move. Now, I'm not going to go over again how a bug behaves in GridWorld. If you don't remember what that's like, I would suggest you pause it at this point. Go run the first project and observe how a bug can move. So yeah, go ahead and pause it and do that if you need to, but we're going to keep moving forward here. So as you can see, our canMove method is a predicate method. I'm trying to move my mouse here to kind of highlight it, but it's a screenshot, so I can't highlight it here in OneNote. But what I can do is do this, right? So it is a predicate method. That's why it's a Boolean. Our first line in the canMove method retrieves the grid from the GridWorld. GetGrid is part of the actor class. It is a method that's inherited. And what getGrid does is it retrieves the grid that the bug is currently in. You can see that getGrid is assigned to the grid variable that is of type grid, and notice that there is also an element tag. So we've talked about element tags in class. We talked about how element tags are used with an array list, and it indicates that it lets you know what that collection is a collection of. So you can see here that grid must be a collection of actors. I'm not going to pull up the Java API because again we only have 7 more minutes now. So if you need to, you can pull up the Java API and take a look at what getGrid does in the actor class. Hopefully my summary is good enough. Now the first thing we're going to do are a variable and check to see if it's null. And the reason why we check to see if it's null is because um, if the bug is not in a grid, I should rephrase that. If the actor is not in a grid, getGrid actually returns a null value. If it is in a grid, it'll return the whole grid object. So we're checking to see if the grid variable gr is null. And if it is null, we're going to return false and let whoever called canMove, we're going to let them know that we can't move because the actor is not in a grid. Now I'm going to switch over to my bug runner driver here very quickly just to point out to you that when we create a bug object, you'll notice there that bug is created, objects being assigned to Ladybug, and in order for it to exist inside of a grid, we actually need to add it to an actor world. So I'm going to create my actor world here very quickly. And if you remember, that is how we add a bug to our actor world. And if we don't execute, if we don't do this line, it's possible to have bugs or actors that are not in grids. So that's why we always have to check. And you're going to see this line a lot where we check to see if the grid is null. And it's something that you're going to want to remember to do for your own projects and for the AP exam as well. All right, so moving on. In line 97, so here's line 97. Right, in line 97, we are retrieving our current location. Right, so that retrieves our current location. And we're assigning it to our variable LOC. LOC contains, or LOC is a variable of type location, and it's going to hold our current location. And the reason why we want our current location is so that we can call get adjacent location in the direction that we're facing. Right? So I may have highlighted too much green here, but again, we use our current location to call the method getAdjacentLocation. Now that method is from the location class. Again, you should pop open the Java API and take a look at the description for what that method does. This is a method that we're going to use a lot of. Actually, most of the location class methods we use a lot. It's very handy, right? It's using that method. I don't need to know what row and column I'm in. I don't need to worry about those numbers. All I have to do is, if I want to know an adjacent location, I just got to call the method with our current location in the direction that we're facing. So the way that works is if we're at, let's say, 5, 5. So I'm going to draw on the screen here a little bit. You know, if my bug is at that location, that's my little ladybug. And if I'm facing north, what will happen is getAdjacentLocation will find the location, and in this case this location, it'll find that location in the direction that the bug is facing. Again, if we use this method, we don't have to worry about what row I'm in, what column I'm in. I don't need to know those numbers. The object itself will store it for me, and you can see that's how it's being used here in this particular method. Once I have that adjacent location, it's going to be stored in the variable next. Right? So LOC, and I'm going to do some highlighting here, LOC is this location in blue, while next is that location in green. Okay. Once I have that variable next, I'm going to move to the next line here. Once I have that variable next, I'm going to highlight it in green. And what we're going to do with it is we're going to check to see if next is not valid. Notice the not operator here in the front. And what we're checking for is we're checking to see if it's not valid. And what is valid, what the isValid method does is it checks to see if a particular location is valid, meaning is it in the grid. And notice that isValid belongs to, I'm going to highlight it here, isValid belongs to gr, and gr was a grid variable. So we're going to check to see if the location is not valid. If it's not valid, we're going to return false. Right? We're returning false here if it's not valid, because if it's the location is not in the grid, we should not move to it. Right? Assuming we can get past that point, and I'm going to go to line 103 now. Assuming we can get past that point, in this line 103, we are going to use the get method to get the actor at the next location I might move to. Right, and that's what the get method does. If there's an actor there, it will retrieve that actor. As you can see, we are assigning it to the neighbor variable, which is of type actor. And the next line, or the lines below it, it's a return statement. Right, we're ending the method. And remember, we are returning true or false. So I'm going to highlight what I'm talking about here. Since I'm returning true or false, you'll notice that those are equality expressions. We're checking to see if neighbor is equal to null. If it is null, meaning get did not return anything. If neighbor is null, there's no actor there, right? It's true. Or if neighbor is an instance of flower. Now that's a new, let me erase these lines here. That's a new operator for you guys, right? Instance of is a new operator. And what instance of does is it lets you know if the object stored at neighbor, if it is an instance of flower. In other words, whatever actor is there is an instance of flower. So let's look at this. We're hitting the 10-minute mark now, so I'm going to end this pretty soon. But let's look at this statement as a whole, and I'm going to try to highlight what I'm talking about here. So this statement as a whole is a pretty big deal. It's being separated by, I'm going to highlight it again, it's being separated by an OR operator. So on both sides are Boolean expressions. Now the one on the left side, the one that says, I'm going to highlight it for you, the one that says neighbor is equal to no, if it's true, because of short circuit evaluation, the expression on the right is never checked. Okay? And that works out for us because if neighbor is null, it means that there is no actor there, and I'm not going to get a logic error executing the expression on the right. Because the expression on the right is checking to see if neighbor is an instance of flower. And you would think that would be a logic error, because how can you check for null and check to see if it's an instance of flower? But we're not. Right? Short circuit evaluation allows us to end this entire expression right away if the expression on the left is true. Now if it's false, if neighbor is not null, then we are going to check the expression on the right. And if it's a flower, then the return statement will return true. If it's not a flower and it's any other kind of actor, we're going to return false and let the user know we can't move. Okay, well that takes care of the canMove method for the actor class. Hopefully that helped you. Again, this was the first video of hopefully of many. So give me feedback. Let me know in class, or if you're not comfortable telling me in person, feel free to email me at drlaw@cps.edu. All right, hopefully you guys are having a good break. Thank you.